Hello, my name is Damien Fair, and I will be talking about the ABCD imaging measures for this ReproNim course. So there are a few learning objectives for this lecture. One is we'll talk about the imaging protocol and pulse sequences, both for both structural and functional. We'll talk a little bit about the quality assurance of the data and the quality control measures, a brief description of the fMRI task descriptions, justification, age appropriateness of the tasks, and the relevance to the ABCD study. We'll highlight the outputs and the of the minimally processed pipelines, and we'll discuss the ABCC or ABCD bids community collection. Okay, imaging protocol and pulse sequences. So most of what I'll be talking about here can be identified on or in this paper with first author by B.J. Casey, the ABCD study, the imaging acquisition across 21 sites. It contains most of the information that is held true for the length and duration of the study. The actual imaging protocol consists of a few different sections. First, there's a pre-scan, which is about 25 to 45 minutes, where there's screening for contraindications for MRI, simulation and motion compliance training, practice of fMRI tasks, and a pre-scan questionnaire. From there, participants are added to our sites can choose from either a single scan session, which most sites do, or a two-scan session, but you can see the specific times here, which include a localizer, T1 weighted image, resting state functional activity, DTI, T2 image, task, and the various task-based fMRI tasks. From there, there's a post-scan around 15 to 20 minutes, which includes a post-scan questionnaire, recognition memory test, and a post-MID survey. The scan protocol for ABCD is harmonized across all the different vendors, so Siemens, Prisma, and Philips. The sequences across the different modalities were relatively close in nature as far as getting the parameters set. There has been several different modifications or changes in software parameters for these for each of the vendors over the course of the study. Those are controlled for by quality control measures that are done at the DIRC with phantoms and human phantoms, but the protocol has stayed true for the study over the course of time. The imaging protocol is approximately 15 to 20 minutes long of the data being collected. This is for rest. This was based on early papers starting in 2015 by a paper by Tim Lauman and another paper by Evan Gordon in 2017, which showed that you begin to get some stability or increased stability of the functional connectivity signal, particularly for parcellated regions of interest at approximately 20 minutes. It's not as long as many people had hoped, up to 50 to 100 minutes, but it's as much as you could get at a protocol this long, and that is held true for the course of the study. Now, it turns out there's a nice publication that recently came out in July of 2025 by Thomas Yo's group, which has highlighted kind of the economy of time using resting state functional connectivity MRI. And it turns out that the economy of scale for studies like ABCD around 20 minutes is a good knee, which provides good economy. So we feel um, feel pretty good about some of those initial choices. But everybody should go ahead and should check out this paper. Okay, on quality assurance. We're now at release 6.0, and there's been a lot of big changes to both the quality control and quality control measures and what's recommended and how that information is represented for the data set. I'm putting a link up here, which goes to the ABCD docs page, which takes you straight to the recommended criteria for imaging inclusion. Please take a look at that link. You can easily navigate it from docs.abcdstudy.org. But in here are quality control measures across many different domains using the new variable naming and table naming standards that have been implemented for 6.0. And you'll be able to look at each of the specific domains and some of the details of this. And here I encourage people to go look. There are the recommended imaging criteria are of several fronts, and they can be identified or viewed exactly how they look using that in this particular location. So just as an example, this is the T1 data recommendation for inclusion, which will be represented by a variable that you can see here. One meaning to include, a zero meaning not to exclude. And that criteria is then based on a few different categories. So the T1 data passed the raw QC, which tells you the instrument and what the element value is in there. That if the free cipher QC didn't fail, which you can see the parameter sets here, and that the derived results from using this parameter actually exist, meaning they got all the way through. Those are the criteria. It's just an example for what the recommendations for including or not including the T1. Again, all this information is very well documented in the new documentation. Okay, there are several protocol compliance checks that are also performed by during the data journey of the data. So there's actual on-site compliance checks at the workstations that provide feedback to the scan operators. The auto compliance series are reviewed by DAIRC staff and corrected when needed by working with the sites. And criteria include, whether key imaging parameters match unexpected values for a given scanner, such as the voxel size, repetition times, things like that, that the data was acquired in the right way, whether there's a presence or absence of B0 or all the right series, for a given modality. And it's also checked for that there's actually total completeness, so there's no missing files. This is also a very important part of our quality assurance measures. There are several of the automated QC measures on top of some of the of those general quality assurance. So taking mean and standard deviation of brain values and spatial SNR. Diffusion MRI, there's mean motion or average displacement measures that are calculated, as well as identifying the number of slices affected by dropout or head motion. For fMRI, there's mean motion or based on frame-wise displacement, the number of seconds of good quality data at a given threshold, and also TSNR maps. The process of quality assurance includes, as noted before, both manual review of the data. So all the T1s and T2s are manually reviewed based on a specific standard and can be categorized as accept or reject. The types of images reviewed, as you can see here, include the T1, T2, the diffusion field maps, the fMRI, and the fMRI field maps. Not all the raw images are reviewed for every single modality, but as many as possible is examined. And the inspection is looking for different signs of artifacts, so poor image quality, presence of wraparound artifacts, whether the brain's cut off, although there is some automated measures for that now. um, susceptibility artifacts, and obviously specific motion artifacts. There's also manual QC of the surface files, along with some of the automated measures that come out of FreeSurfer. Um, so reviewers assign here a binary score of reject or accept based on how well based on the level of number of artifacts and irregularities. Um, they look at motion, intensity, inhomogeneity, white matter underestimation, peel overestimation, susceptibility artifacts, and again, assign some scores for the QC measures. Diffusion. Measuring the post-processing QC is very similar, looking for artifacts and irregularities. There's recommendations of the exclusion or not, based on some of those irregularities. And what's examined is B0 warping, same motion artifacts, head coverage, registration with T1, accuracy of the segmentations, and so forth. For the manual part of the fMRI, it's looking for same types of artifacts or irregularities, um, B0 warping, head coverage again, and similarly, the QC scores include a scale from 0 to 3. Importantly, not every participant, can be manually reviewed. So, but a subset is viewed based on the propensity of having artifacts or not, using some automated measures. Several automated post-processing QC measures are actually also occur. So as you can see from FreeSurfer, the topological defects, field of view and brain cutoffs, um, the estimation of geometric registration discrepancy with respect to the T1 scan, and other measures that you can see here. Quantified intersection of brain mass with frame borders. These are other measures that can be that tell us the quality of the data, that's more in an automated fashion. Okay, so back again, just reminding folks here that all of this measures that we've been described here are now neatly categorized in tables, with clear instrument names and variable names that you can kind of see here. Again, just showing the full indicator for this case, again, T1, the 0 or 1, meaning to include or exclude, and then what criteria are used to essentially provide that final QC measure. This is T1. Here's just another example of a T2, which includes you can see some of these additional measures, including the T1 raw QC, FreeSurfer, manual post-processing, the registrations between the two images, and that the derived results exist. I'm going to go through the rest of these relatively quickly so we can get to some of the other pieces because there's lots of detail here. Again, all this information is very well neatly displayed in the docs page. So I encourage everybody to look at that. But there's same criteria are set up for diffusion MRI, for resting state, functional connectivity MRI, the MID task, the NBAC task, and the SST. Okay, so fMRI task description, justification, age appropriateness, and relevance to the ABCD study. Okay, the first here is the monetary incentive delay task. Participants attempt to win or avoid losing money by responding to cued stimuli using a response box on their dominant hand, as you can see here. Many folks who leverage the ABCD data are now quite familiar with this. There's 50 contiguous trials, 10 trials per type, each in 2 runs. The target duration is based on the participant's performance during the practice session prior to scanning, as noted earlier, and adjusted during the scanning with an adaptive algorithm. Task is translated into actual payment amounts for the participants. Here's the stop signals task. The SST presented leftward and rightward facing arrows in serial order for the go stimuli. The participants are instructed to respond as quickly and as accurately as possible, but we're told not to respond to trials in which a left or right arrow was followed by an arrow pointing upward, i.e. the stop signal. There are 2 runs, each have 180 trials, of which 30 are the stop trials. The time between the go and the stop signals, the stop signal delay varied dynamically in a participant's success on the prior trials to achieve a 50% success rate. Here's a picture of the emotional end-back task. 2 runs. Each run contains 8 blocks, half of which are 0 back and half are 2 back. Each block contains 10 trials, 2 of which are targets. The face stimuli include happy, fearful, neutral facial expressions from the NIM stim and racially diverse affective expressions set of stimuli. In addition, the images of places was used as the 4th stimuli. And just showing here the aspect of the afterward of scanning, and this is the specifics of the recognition memory test. Okay, the tasks were chosen here with these specific criteria in mind for ABCD 1.0. Their implications in addiction, with highlighting validity, the feasibility in developmental studies. That means that they can be done and they're developmentally appropriate. Well-characterized neural activations like specificity, reliable activation over time with subjects, reliability, consistent patterns of activity across subjects or sensitivity, and leveraging of other complementary developmental imaging initiatives that use similar measures, the generalizability. This is just a highlight of the specific fMRI tasks descriptions and what domain and what potential neurocorrelates. There's been several papers out on these tasks now, which is providing a lot of information about how these tasks work and their neural sequelae. And we'll hopefully talk a little bit more about that in a bit. There has been some work over the last several years, which is highlighting the reliability and reproducibility of these tasks. I encourage people to go look at this paper from 2021, which are highlighting the number of participants to reach reliability within a given modality. Here's just showing the SST. Both with cortical and subcortical activation and correlation. Here's the same maps and figures for the NBAC. Very robust task, as you can see on the right. And sorry again here for the NBAC, and this comparing the different conditions. Faces and places, negative versus neutral faces, positive versus neutral faces, and so on, both cortical and subcortical. The MID. Okay. So now we'll move on to talking about how the data are actually processed using the minimally processed pipelines. And then we'll move on from there to talk about the ABCC. Okay, so the initial paper of the imaging processing pipelines you can identify in here. was first described by Don Hagler here and Sean Hatton. These pipelines have stayed true for the longevity of this study. There's been several updates over time, so we encourage people to use the new data, the 6.0 data, which has corrected prior errors and has improved on some of the processes. Um, but this gives you a general outline of these minimally processing pipelines. Okay, for structural MRI, it's T1 and T2. There are several, aspects of the processing pipelines: gradient nonlinearity distortion correction for the structural images, registration of the T2 images to the T1 images using mutual information and atlas-based pre-registration, intensity non-uniform correction of white matter bias, WMBC. This is based on tissue segmentations, resampling into rigid body registration with custom atlas of 1 millimeter isotropic voxels, and then brain segmentations and cortical surface reconstruction from T1 imaging using FreeSurf, which is now up to 6.0. There are several derived measures that are from the structural images that you can find in the tabulated data in particular. So morphometric measures and cortical thickness, area, volume, and suckle depth, image intensity measures on T1 and T2 and various contrast, cortical surface ROIs using standard FreeSurf parcellations, but also subcortical ROIs, intensity-based measures and volumes. Diffusion MRI and restricted spectrum imaging diffusion. So with the diffusion, minimally processed pre-processed data for diffusion includes head motion correction. Correction of spatial distortions, robust tensor estimation, registration of the T2 images to B0 images, and then resampled into a standard orientation, 1.7 millimeter isotropic voxels. There's several derived measures that again are primarily in the tabulated data. That includes diffusion tensors. So as most people are familiar with, that also includes restriction spectrum imaging, or RSI, and the average diffusion derived metrics on specific white matter tracks, subcortical gray matter structures, etc. And now for the resting state functional connectivity. This also goes through B0 distortion correction using reverse gradient methods, gradient nonlinear distortion, head motion correction, and then registration to T1. There are removal of some of the initial volumes. It's different between the different vendors, as you can see here. The data are normalized and detrended for time courses, regressed out signals related to motion, white matter, ventricles, whole brain, and volumes with excessive motion greater than 0.2 and five contiguous frames are also removed, and respiratory artifacts are removed. There's a bandpass filter of, as you can see here, 0.009 to 0.08. And then the voxel time series data are resampled to surface cortical meshes. There are several analyses that are available in some of the data. So there's in some parts there's matrices that are now developed, so that pairwise correlations between various ROIs, average correlations between predefined networks, and correlations between each subcortical RI and each network. These types of analyses are available in now file-based and concatenated data as file-based data, but is also available in the tabular data. And for the task fMRI. There are various task fMRI specific processing. You can see that there's a generation of gender linear model using Afni's 3D Convolve. There's nuisance regressors. There's filtering of motion timeframes based on an FD of greater than 0.9. And the hemodynamic response is modeled, as you can see here, using Afni's SBMG model. The MIDB and SST models, events are modeled as instantaneous. You can see here some of the details for the modeling of the NBAC task too. Looking at timers. So GLM coefficients and the T statistics are sampled onto the cortical surface, and there are several ROI analyses and statistics that are available, both in file-based and tabular data now. And last bit on this particular section is that all of the data, both the raw data and the derived data from the minimally processed pipelines and the free surfer outputs are available in BIDS format or BIDS derivatives. In the pipelines, a work towards the next round, hopefully 7.0, that the pipelines will be also converted into BIDS apps and hopefully made a bit more user-friendly. All right, and the last bit here today is on the ABCC or the ABCD BIDS community collection. So the ABCC data used to be on the NDA, and it was called ABCD-3165. But this data was designed to supplement current data sharing with an accessible platform for community sharing of derived data. It assists investigators in conducting state-of-the-art statistical analysis using software packages designed to work with BIDS data sets, provides integrated data and analytic utilities for results verification, and so on and so forth. On the docs page, there's a separate section in the docs that are specifically highlight the ABCC data and what all this data contains, and I'll be able to go over a few of that with you right now today. Importance is that the collection enables our community contributions and usage. It's got standardized formatting, a governance structure for contributions to maintain compliance with the MBDC's important data usage standards, which is important for folks to follow and read closely. This is actually a little bit of an old slide, but it just gives you a basic idea of the bid structure and how the ABCC is kind of set up. The names have slightly changed with the ABCD 6.0, but please look at the documentation to specifically highlight how this is all organized. But it has both the raw data and the derived data for folks' usage. I'm gonna play a little video here for you all so that you can hopefully see and hear how to access the ABCC data on the new LASSO platform. You undoubtedly saw about the LASSO platform in another instructional video, but this will give you an idea of where to look for the ABCC data specifically in the platform.
So this is the first way you can query the data. Again, we're in the ABCD toggle and all study data search and filter menu item. So here you can see that we're looking at different raw modality data, and you can select your query of interest by toggling the switches on and off. As you toggle, you'll be able to see what different file types you'll have access to. And based on what toggles you have switched on and off, you'll have information about your download size, the number of files, and the number of participants. You'll also have derivative and source data that you can also make your selections and your queries. And as you adjust your queries, your file size, download size, and number of participants will also adjust. You'll also have ABCC collection access as well here, both raw and derivative data. You'll also have the ability to switch over to your tabular data and toggle on and off the instruments that you are interested in. And it looks very similar in the sense that you'll also be able to see what file types are associated with each instrument. So you can make your data selections in a really easy toggle fashion. Because these are large amounts of data, you will have the option to filter for only a subset of participants if you're not interested in the entire ABCD study cohort. Or if you're interested in just taking a quick look at a few participants, you can also just designate a number of participants that you're interested in downloading their data for. And you can just download a handful of participants to take a peek at what it looks like. So this is the first.
Okay. So the key for accessing the ABCC data, as you can see, is you can toggle back and forth between the ABCD data center and the ABCC collection here. And all of the files, both on both sides, are organized as you would see them on the file system as bids data sets and derivatives. In one of the things that would be of note for 6.0, the ABCD 6.0, is that the ABCC data and the ABCD data center data both have their own raw data for which those derivatives came from. For 7.0 release, so this coming up next year, the raw bids data will be integrated across the data sets, so there'll be only one raw bids data folder, and then separate derivatives for the community derived collection and then the data center collection. There are several pipelines and utilities related to ABCC. But just highlight a few here. They're using common standard tools. Everything's typically all Dockerized in standard outputs, minimalist interface, etc. Just as one example, this is the ABCD bids or ABCD HCP pipeline is based on the HCP studies or HCP pipelines that does free surfer, post free surfer, volumes, surface, and then several aspects of pre-processing. The two in the current collection, which is now with 3.0, and coming will actually be 4.0. There's ABCD HCP pipeline derived data, QSI prep derived data for diffusion, and coming will be fMRI prep, the derived data, XCPD derived data, QSI recon derived data. Which should be coming soon. All the data, all of the workflows and pipelines on the ABCC have gone through a bit of software standardization through the Nbind Collective. You can see the website down here. There are lots of tools in here. Here's actually the ABCD HCP pipeline, and they go through some basic standardization and scoring based on seems a bronze, a silver, gold type scoring, which describes how well their testing infrastructure and documentation is for lots of different tools, including everything in the ABCC. There have been lots of updates to the fMRI prep workflows to kind of to harmonize the outputs with the HCP and ABCD bids pipelines. There's a paper on this that folks can. It's a preprint, but folks can be able to look at that. And it's also the same harmonized infrastructure for the HBCD study, but you'll see in that work. A few other highlights here are some more recent papers since the last time we did this course, both for XCPD and QSI prep. Folks can check out those papers and the work. There's a lot of details in there about how these workflows that are in the ABCC are designed and implemented. So there are a few highlights around these utilities. One is they typically have a minimalistic interface, detects any modality configuration. This is kind of the BIDS, standard. Pre-surfer, post-pre-surfer modifications improve performance on certain data sets. There's study-specific templates. There's several connectivity preprocessing modules, artifact filtering parameters, and lots of quality control modules for to make sure the data are good quality. The utilities work with ABCD data, legacy non-ABCD data sets, specialized population and aging, and like I said, they work with the HBCD data too. So if folks are interested in following up this with understanding what the tools are in HBCD and how they're harmonized with these tools, there's some additional documentation that I'm showing here. These are actually a lot of those tools, which include MRI QCs. We highlighted infant fMRI prep or now fMRI prep lifespan, XCPD, QSI prep, and QSI recon, etc. Here's just a few examples of some of the quality control measures. These are called gray plots. It allows you to, for any given subject, for every session and run an ABCD, which allows you to look very specifically at artifacts and bold data. As you can see here, like artifacts and bold data, causing massive changes in gray matter structure. Measures of the frame displacement, as you can see down here, and how those are corrected with some of the respiratory filters that you can see down here, and so on. A lot of this work and documentation is available for you to see. Several web-based HTML from fMRI prep. Here's one from the executive summaries from both XCPD and the ABCD BIDS apps, just highlighting different ways to look at the quality of services in an easy way and registrations and so on. There have been a lot of papers and works that have come out of the ABCC since its inception about 6 years ago or so. A lot of these papers folks are familiar with. Go check them out. The data are available for you to leverage. Wanted to highlight just one of the papers here, and that is the importance of large data sets like the ABCD data. In how big collaborations like the ones that we're showing here and the leveraging of ABCC and the ABCD data have allowed to really understand lots of specifics and importance of doing and how to do our science. This paper just highlighted, in which a lot of people are familiar with now, is just how small effects, the small effect sizes that we're actually dealing with with brain imaging studies, and the importance of large studies, showing that if you're asking very basic questions about what are the effect sizes of brain behavior correlations, you realize that they're actually quite small and require extremely large sample sizes. And so folks are coming up with all types of creative ways now to leverage studies like ABCD to handle smaller samples, but even with small effect sizes. The ABCC has a few other additional nuggets. There are the ARMS, which are the ABCD reproducible match samples, which essentially break up all the participants based on the baseline data into two, demographically equally defined groups, and a third group for model development. Here's just giving a quick look at some of the demographics, here of these specific groups, showing counts across all these different measures of demographics and family structures and whatnot. It highlights the ability. Oops, still have some old stuff here in here, but highlights how these works highlight how you can take connectivity matrices from one of those arms and another one from the other one You look at the difference, and you can see that based on averaging averaging across samples, and you can almost get point estimates of the reliability of things like these connectivity matrices or other measures like cortical thickness, as you can see on the right. But really, these samples are really leveraged to highlight and to redo analyses for reproducibility purposes. And in fact, if you're looking now at the brain behavior correlations, you can see how many samples are required to obtain reliable relationships. In this case, it's with the measure of generability across these two measurements, but shows that the reliability, if we have enough people, upwards of 3,000 people in each sample, that you can see what level of reliability. And that's really kind of what these tools are for. So I'm going to end there. I just want to highlight that there is a place to get help. Where you can issue tickets for on the Lasso platform if there are issues or things that you need help with. There is specific documentations on where to go for that. There's another location for frequently asked questions, but also has additional emails for folks to email the study teams in case there is issues or help needed for your work. Just highlighting the Help Center on Lasso platform, the new MBDC platform. This is for both ABCD and HBCD, and it will guide you through how to create issues, managing tickets, and also point you to documentation that's both external, but also internal in case it has unique IDs in it. And then last, just pointing out, there's lots of different training videos on how to use the platform and hopefully this will help people navigate working with the ABCD data and just in general. So I'll end there and just say thank you for having me, and hopefully this is helpful in your pursuits of analyzing the ABCD data. Thank you.